Okay, tonight's lesson is on complex numbers. So a complex number is made up of a real part and an imaginary part. So for example, a real part might be 5, and I'll add on an imaginary part of 2i. I is your imaginary number, and it's equal to the square root of -1. So anytime you have a radical with a negative radicand, this will have an imaginary part, which is the -1. So you need to memorize this. I is equal to -1, square root of -1. So here is a complex number, 5 plus 2i, the real part, and this is the imaginary part. So the first thing we're going to look at is adding complex numbers together. So let's take a look at 5 plus 2i plus, let's say, 3 minus 4i. So when adding and subtracting, you want to only add or subtract the real parts together. So we're going to add the 5 and the 3. Okay, and then we're going to add the imaginary parts together. So 2 plus -4i. And you add and subtract just like you would like terms. And so this would be the answer to that addition problem. Okay, so let's take a look. Let's subtract these two complex numbers. Okay, so again, subtracting the real part, we get 2. Subtracting the imaginary part, 2 minus -4 is +6. Okay, let's take a look at multiplying. So we multiply just like we would do when we multiply two binary numbers. Sorry, I misspoke. Binomials, not binary. Binomials, when we multiply two binomials together. So I'm going to go ahead and use the FOIL method here. So multiplying my first terms, my outer terms, my inner terms, and my last terms. Now this is the tricky part, because we're going to multiply 2 times -4 and I times I. Now we're going to go ahead and combine like terms. So at this point we have -20i plus 6i Now before we can continue, we need to know what I squared is. So in order to do that, we're going to go back over here and we want to find out what I squared equals. And I'm going to have to turn off this Christmas music, it's kind of annoying. So to figure out what I squared is, we're going to square both sides. So if I square this side, I get I squared. Remember, whatever you do to one side, you do to the other side. So if I square this side, I get I squared. And then if I square this side, I get the square root of -1 squared. Well, the square root and the square cancels out, and so we know that I squared is equal to -1. So we can substitute that in for I squared. So we end up with -8 times -1, which is +8. Okay, Combining like terms, 15 plus 8 is 23. And remember, never combine an imaginary number with a real number. Complex number, real part, imaginary part. Okay? Next thing we're going to do is we're going to do some division. So let's divide our two complex numbers. So 5 plus 2i divided by 3 minus 4i. Now, in order to handle this, what we need to do is multiply by what's known as the conjugate. Important word you need to know. So the conjugate, we're going to take the conjugate of the denominator. And to get the conjugate, we just change the sign of the imaginary number. So if it's minus, the conjugate is going to be plus. We multiply the top and the bottom. Now we're really not doing anything to this fraction because anything divided by itself is 1. So we're multiplying by 1. We're just changing this format. We don't want to have an imaginary part in the denominator. That's the point here. Just like, remember how we learned that we don't want a square root in the denominator, and we had to multiply by the denominator over itself, and we would get, this would be the square root of 9, and the square root of 9 is 3, so we'd have 2 square root of 3 over 3. Where we did not want to have the square root in the denominator, we do not want to have the imaginary part in the denominator either. It's going to go away. So let's go ahead and do this. Little extra work here. We have to multiply those together in the numerator. Numerator times numerator. Let's do it quickly. First terms, 15. Outer terms, 20i. Inner terms, 6i. And last terms, 2 times 4 is 8. I times I is I squared. Okay, now doing the denominator, same thing. First terms, remember we're multiplying these binomials together. First terms, 9. Outer term, 12i. Inner term, negative 12i. And last terms, that's going to be negative 16. And I times I is I squared. Okay, substituting in for I squared. Memorize this. I squared is negative 1. So we're substituting in a negative 1 in here and a negative 1 in here. So we get so this is going to be 8 times negative 1, which is negative 8. Negative 8 plus 15 is 7. Combining our imaginary, we get 26i. Okay, negative 16 times negative 1 is 16. 16 plus 9 is 25. And 12i minus 12i cancels. Notice no imaginary part in the denominator. There you have it. Let's go back up here real quick and look at, we know what I equals. We know what I squared equals. Let's take a look at what is I cubed equal. Well, I cubed is going to be equal to I times I squared. Remember, when multiplying like bases, you add the exponents. So 2 plus 1 is 3. And we know that I squared is equal to negative 1, so this is going to be I times negative 1. And so I cubed is going to be equal to negative 1 times I, which is negative I. So I cubed is equal to negative I. And then we have I to the 4th. Well, that one is going to be I squared times I squared. I'm going to use that one because 2 plus 2 is 4. And we know that I squared is equal to negative 1, so it's going to be negative 1 times negative 1, which is 1. Okay? These are the 4 that you need to know. This one's especially important, and of course this one is. So, these are going to help us with solving or simplifying something that might look like this. I to the 40th power. So to solve this, what you want to do is, the way I do it, since I to the 4th is equal to 1, I want to find out how many 4's go into 40. 10. So if I do I to the 4th, which I know is 1, and 4 times 10 is 40, what I have here is 1 to the 10th power, which is 1 times 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 1, which is 1. So I to the 40th power is 1. Let's try another one. I to the 401 power. So I like to use I to the 4th because I know that's equal to 1. So 4 goes into 401 100 times. 4 times 100 is 400. So that means I have 1 left over. So times I to the 1st power. So 1 to the 100th power is 1. And 1 times I is I. So I to the 401 power is I. You getting it? Let's try one more. I to the 27th power. So I like to do the I to the 4th. You can do any combination you like. Oopsie. 4 goes into 27 6 times. 4 times 26 is 24. And what's our remainder? 3. So I know that 1, this is going to be 1. 1 to the 6th power is 1. Okay, and 1 times I to the 3rd, we know that I to the 3rd, if we look back up here, I to the 3rd is negative I. So I to the 27th power simplifies to negative I. Okay, lastly, running out of time, if I have the square root of negative, let's say 16, I'm going to break that down. See the negative? That means that we have an imaginary part. So I'm going to break this down to the square root of negative 1 times the square root of 16. That's going to produce my I, and the square root of 16 is 4. So if I wanted to simplify this, that's the process I would use. Always break it down.